All right, so we're going to do a little bit of an extension from the last lesson on logs. Um, so just a refresher from Algebra 1, if I had x squared times x to the third in Algebra 1, remember x squared is two x's, x times x to the third is x times x times x. So altogether we are multiplying five x's here. So this is the same thing as x to the fifth. To refresh your memory, all you have to do the shortcut is just go ahead and do x to the second plus 2 plus 3 is equal to x to the fifth. Okay, so how that translates into logs, so we're going to do a log problem, is if we have a log of 2 of 3x, let's say, and I know that the operation in between here is multiplication. So how you split that up is you basically split this up. The log base 2 is the same for both of them. So what do I mean by that? You do log base 2 of 3, and then the times, just like the times here, became a plus sign. So it becomes plus, and again, the log base 2 is going to be shared. So you do log base 2 of x. So this is how you expand logs, okay? Well, we'll do a few more, and you'll get the hang of it. But I want to teach you the rules first, right? So multiplication means that you add. So multiplication changes to addition, okay? To refresh your memory again with division, right? If I had x to the fifth divided by x to the third, you would really do x to the 5 minus 3, which is equal to x to the second power. And so how that applies to logs is very similar, right? This is, I'm going to go ahead and do logs now. So with logs, if you had log of 5 x divided by y, right? Division changes into subtraction. So how you would make it bigger or expand it is log base 5 of x. Again, division changes to subtraction, so minus log base 5 of y, right? Whatever's on top goes first, the second one goes on the bottom. So this is how you would expand that. The last rule before we go over a couple of examples is anytime you have, I'll do this in green, if you have x to the second power to the third power, what that means is you have x to the second times x to the second times x to the second, right? You're raising it to the third power, which means that you're multiplying the same thing, whatever's in parentheses, by itself 3 times. So the shortcut here is just to do x to the 2 times 3. You multiply these two, and that becomes x to the sixth, okay? How does that translate into logs? So to logs, I'm going to go ahead and kind of loop around over here. When it comes to logs, what you're going to do, and again, I'll do this in green for our last rule, is if you have log, oh, I said I was going to do this in green. Let me just go back to green. Come on. There we go. Log based 5 of x to the second power, all you do is this 2 gets kicked, the exponent gets kicked to the front. So it becomes 2 log base 5 of x. 2 log base 5 of x. And this is our last rule. So this is in your notes. It kind of goes over, this is the Algebra 1 part, and this is the Algebra 2 part when it comes to logs, and we'll go over a couple of examples, okay? All right, so let's go ahead and use purple. This is log, there's no base. If there's no base, there's an imaginary 10. For this problem, you don't need to know that. If there's no operation in between it, it's always going to be multiplication. So we learned in the last slide that multiplication changes into addition. So we're going to expand this. So it's going to be log, and again, if there's no base, it's base 10. We're going to leave that alone, of x squared, right? Multiplication becomes addition, and then you do log base 10, and again, the 10 is implied, so you don't need to write that down, of y to the fifth power, okay? So that's step one. we learned in rule number 3, which is the power rule, right? This one right here. We learned that if you have an exponent, it can get kicked to the front. So let's go ahead and apply that to this problem, okay? So here we have an exponent, and this exponent is going to get kicked to the front. So this is the same thing as 2 log, again, there's an implied base of 10x plus the 5 that's here gets kicked to the front as well. So 5 log x, log of x. So this right here is how you would expand the log. Okay, we're going to do condense in a bit, but let's just do a couple more problems with this. Okay, so here again, there's a multiplication symbol right there, implied multiplication. So we put an equal sign. So this is going to be log. Again, the base is 10 because there is no base of 5. Multiplication changes to addition. Log x to the 4th. And then for our second rule, right, we're going to take that exponent, we're going to kick it to the front. Here, there is no exponent, so there's nothing for us to do. So we're just going to put it equals. We're going to leave that first one alone. Plus, and again, this exponent's going to get kicked to the front. So 4 log of x. Okay. If you are wondering why this rule happens, let me know and I'll go over that with you in class. Okay. All right. So this one is just the same thing, except now you're doing, it's a little bit more intricate. So here there's a multiplication and here there's a division. So we're going to split this up as log of x. The times becomes a plus. Log of y to the 3rd. We can kick that to the front in the next line. But then the division sign, which I did like that, right? That's not right. Division changes into subtraction. Let me just go ahead and write that down. So division, right? This right here changes into a subtraction symbol. So it's going to be log of z to the 2nd power. Okay. Now let's go ahead and take any exponents. Like this one, there is no exponent, so we're going to leave it as log of x. Here, our exponent's going to get kicked to the front, so plus 3 log y minus, here we have an exponent, let's kick it to the front, 2 log of z. So this here is our whole answer. All right. Here we're going to go backwards. We're going to condense the log. So addition, when we're condensing, changes into multiplication. So I'm going to rewrite this as log base b of 6 times 7. And so I can make this better, right? Instead of 6 times 7, it's going to be log base b, and 6 times 7 is equal to 42. So this is my final answer. Okay. Remember to be pausing the video and taking notes, slowing it down, because I am going kind of quick. All right. Condense the log. So here I have a plus sign again. So that's going to change into multiplication. So I'm going to do, when I condense, I'm only going to write log once. So it's log of a. Addition changes into multiplication. So it's going to be times. This 2 is going to get kicked back as the exponent because now I'm doing the reverse. So the 2 is going to get kicked back. So it's going to be times c to the 2nd power. Let's see if I can write that a little bit better. I can put parentheses around this. So I can rewrite it as log base 10 because there's no 10, but I don't need to write that. Instead of the little dot, I could just leave it as AC squared. And this is my final answer. All right, last problem. So again, addition changes into multiplication. Since it's condensed, I'm going to have a single log. So it's going to be a d times, I'm going to put the little dot there for now. This x gets kicked as the exponent. So it's going to be k to the x power. And again, I'm going to make that a little bit better without that little dot right there. So it's going to be log of d k to the x. Okay. So on Delta Math, there's a couple of problems for you to try. Please let me know If you have questions, this is not an easy lesson, which is why not everyone's doing it. But let me know if you need help. All right.